Good evening everyone. Today we are going to discuss the simple linear regression. In simple linear regression, we will first understand the equation involved in the simple linear regression, that is y is equal to beta naught plus beta 1 into x. Now, what is y here? Y is our dependent variable. What is our beta naught? Beta naught is our intercept, the value of the y when our x is equal to 0. And what is beta 1? Beta 1 is the slope, and x is what? X is our independent feature. Okay, now we will see the cost function involved in this. Cost function. So first of all, we need to understand that what is cost function. The cost function is nothing but a mathematical formula which tells the difference between our predicted value and the real value. And in simple linear regression, we calculate the square of the difference. Like just we have seen that this is the equation. So what is this equation? This is the equation which will give me the value predicted by my model, that is y hat is equal to, y hat means the predicted value by the model. Now if I do the true value minus my predicted value only, so this error can be positive as well as negative. And if I will sum all the errors, may some of the errors get cancelled out, which is wrong. So what we do is we just square the value. So now all the values that will come out of this equation will be positive, and we will get our correct error for all the points in the data set. Now I will be telling you what is the mathematical equation for finding the cost function in the simple linear regression. Let's see it. That I have j beta naught beta 1, that is equal to 1 by 2 m summation of I is equal to 1 to m and y of I minus y hat whole square. Okay, so let's see here what are the points involved in this point, where m represents my total number of points in the data set, where my yi represents the actual value and my y hat represents the predicted value for a given point. Okay, so I have already told you why we do the square. Let's see here. I have multiplied 1 by 2m. I have divided it by m to get an average value, and I have multiplied it by 1 by 2 because on further when we will take its slope, that is the gradient descent, then this 2 will cancel out the 2 which will be coming from the derivative. Just see here, for example, if we have some x square and I do the derivative, I know that I will be coming out with 2x. So on doing the derivative of this value, we can simply see that the 2 will be coming in front of the equation and our 1 by 2 will be cancelling it out. So this is the purpose why we multiply it with 1 by 2. Now our goal will be to choose a value that is beta naught and beta 1, which will reduce my cost function, because cost function if will be high, then my predicted value and the real value will be at more difference. Now just see, the beta naught and beta 1 can get infinite number of values, and if I go on plotting the and checking for the infinite number of values, this is not possible. So we have find another approach, that is the convergence. What we do in the convergence is that if we see here that suppose I plot a graph for the cost function and I get like this. I have to reach to this point. This point is called as the global minima. And for reaching this global minima, what I will do is I will be derivating my cost function equation with respect to intercept and with respect to the slope also. And convergence means what? Convergence means we will be doing an iterative process that we will update our beta naught and beta 1 value until we reach this global minima point, that is our cost function approximately value becomes 0. So on above we can see the cost function equation is this, and now what I will do is I will update my beta naught and beta 1 values. The beta naught updated value will be beta naught minus alpha differentiation of my cost function with respect to the beta naught. Okay, and for the beta 1 also it will be beta 1 minus differentiation of the cost function with respect to the beta 1. So just see here, what I will do is I will partially differentiate my cost function with respect to beta naught, and I will get another updated value of the beta naught, and similarly I will do the differentiation of my cost function with respect to beta 1, and I will again get an updated value for the beta 1. The alpha here indicates the learning rate. You can see here an alpha. What alpha tells is that it tells me that how much I should increase or decrease my value so that it can reach to its global minima, and it is taken a small positive value, because if we will take a large value for this, then the step gap will be more between the next updated value, so I may miss my required thing. And if it will be very small, then the algorithm of convergence will become very slow. So I have to choose a right value of alpha that will give me a fast and suitable convergence. Now, the final formula for these two values, that is differentiation of j with respect to beta naught, is equal to minus times of 1 by m summation yi minus y predicted. And the final formula of this is this 1 minus 1 by m summation y of I minus y of hat xi. You need not to differentiate it, you just see that what is the main formula here. And then one question arises is that why we need a gradient or slope that we have calculated here. The gradient and the slope, which I just tell you the formula, it tells me the direction in which the cost function is increasing. So I will just go opposite to the gradient and I will find my minimum cost function value. Now see, what we do is that we initialize our beta naught and beta 1 with a random value, and then I calculate my cost function, and then what I will do is I will update the value of beta naught and beta 1, then I will again check the value of my cost function, and this process will be followed until my cost function becomes a very small value or I reach the maximum steps. Thank you.